Hello everyone, welcome to our class. My name is Ko-Chen Lee. In today's sections, we will talk about performance analysis and logging. And this is today's outline. We will first start with introductions and how to establish performance baselines. Then we will cover monitoring reliabilities and performance, comprehensive performance monitoring, resolving performance bottlenecks, and performance logging. And Windows Server 2008 provides many tools to help you track performance. The key comprehensive monitoring and optimization tools and features available include the following. Performance monitors. Performance monitor can be used to track and display performance information in real time. Reliability monitors tracks changes to the systems and compares them to changes in system stability, thus giving you a graphical representations of the relationship between changes in the system configurations and changes in system stability. And data character sets and reports. Data character sets can be considered to be the logging counterpart to performance monitors. By using data character sets, you can recall performance information in real time and store it in a log so that it can be analyzed in a report later. Performance counter alerts. Performance counter alerts can be used to notify the users when certain events occurred or when certain performance thresholds are reached. And before discussing each of these tools in turn, let's look at how you can establish performance baselines. And one of the key reasons for tracking performance information is to establish a baseline for computers that allows you to compare past performance with current performance. And there are several types of baselines you can use, including the following. Post-installation baselines. A post-installation baseline is a performance label that is meant to represent the way a computer performs after installing all the roles, services, features, and applications that will be used on the systems. And typical usage baselines. A typical usage baseline is a performance label that is meant to represent average usage conditions and serve as a starting point against which you can measure future performance. Test baselines. A test baseline is a performance label you use during testing of a system. In the test lab, you might want to simulate peak usage loads and test how the system performs under these conditions. And monitoring reliability and performance. The Reliability and Performance Monitor Console is the tool of choice for monitoring a system's reliability and performance. With the reliability and performance node selected, you see an overview of resource usage. The resource usage statistics are broken down into 4 utilization categories. CPU. CPU shows the current CPU utilization and the maximum CPU utilization. Disk shows the number of kilobytes per second being read from or returned to disk and the highest percentage usage. And network shows the current network bandwidth utilizations in kilobytes and the percentage of total bandwidth utilization. And memory shows the current memory utilizations and the number of hard forks occurring per second. In reliability and performance, you will find performance monitors and reliability monitors under the monitoring tools node. Performance monitor graphically displays statistics for the set of performance parameters you have selected for display. And these performance parameters are referred to as counters. When you install additional roles, role services, and features on a system, performance monitors might be updated with a set of counters for tracking performance of the related components. And you can update counters when you install additional services and applications as well. And reliability monitor, shown in figure, tracks changes to the servers and compares them to changes in system stability. And in this way, you can see a graphical representation of the relationship between changes in the system configuration and changes in system stability. By recording software installation, software removal, application failures, hardware failures, and the Windows failure events, as well as key events regarding the configuration of the server. And you can see a timeline of changes in both the servers and its reliabilities, and then use this information to pinpoint changes that are causing problems with stability. Reliability and Performance Monitor is a tool designed to track and display performance information in real time. It gathers information on any performance parameters you have configured for monitoring and presents it using a graphical display. Using Performance Monitor when you start a Reliability and Performance Monitor console. And you can access Performance Monitor by expanding the monitoring tools node and then selecting Performance Monitor. Each performance item you want to monitor is defined by the following 3 components. Performance objects represents any system components that has a set of measurable properties. A performance object can be a physical part of operating system, such as the memory, the processors, or the paging file. A logical component, such as a logical disk or print queue. Or a software element, such as a process or a thread. Performance object instance represents single occurrence of performance objects. If a particular object has multiple instances, such as when the computer has multiple processors, and you can use an object instance to track a specific occurrence of that object. And performance counters represents measurable properties of performance objects. And the most commonly tracked performance objects are memory, physical disk, and processors. When you first open Performance Monitor is configured to graph only %processor time counters. Many other performance counters are available for tracking. To track additional counters, you can use the Add Counters dialog box as shown in figures. After you have displayed the Add Counters dialog box, you can select objects and counters to track by completing these steps. First, in the Select Counters from Computer box. And second, adding counters to track is easy. Select the type of object you want to work with, such as memory. Third, when you select an object or any of its counters, you will in most cases see the related instance. Fourth, repeat step 2 and 3 to add other performance parameters. Performance Monitor can present counter statistics in several different ways. By default, it graphs the statistics. A graph is useful when you are tracking a limited number of counters because you can view historical data for each counters that you are working with. And by default, Performance Monitor samples the counters once every second and updates the graph over a 100-second duration. This means at any given time there can be up to 100 seconds worth of data on the graph. If you change the sample interval and directions, you can get more information into chart. For example, if you set the sample interval to once every 10 seconds and the duration to 1,000 seconds, and you can get up to 1,000 seconds or about 17 minutes worth of data on the graph. Monitoring performance on the computer for which you are trying to establish a baseline can screw the results. The reason for this is that Performance Monitor uses resources when it is running, particularly when you are graphing performance information. Taking frequent samples or tracking many performance counters to remove the resource burden, or at least most of it, you should consider monitoring performance remotely. Here you use one computer to monitor the performance of another computer. Although this does generate some extra network traffic, you will get more accurate results for the monitored computer because you are not using its resources for monitoring. And generally, a bottleneck is any conditions that keeps a computer from performing at its best. And bottlenecks can also apply to situations in which one resource is preventing another resource from performing optimally. And for example, if a system doesn't have enough physical memory, it doesn't matter whether it has a fast processors or a slow processor. Resolving memory bottlenecks. Windows applications use lots of memories. If you install a server with a minimal amount of memory required, it's not going to perform at its optimal level. The server cannot perform at its optimal level when you install the recommended amount of memory either. The reason for this is that a server's memory requirements depends on many factors, including the services, components, and applications that are installed on the servers as well as the server's configurations. Computers use both physical and virtual memories. Physical memory is represented by the amount of random access memory installed. And virtual memory is memory returned to a paging files on disk. Reading from and writing to the paging file involves the disk subsistence, and it is much slower than accessing physical memory. Because of this, you don't want the system to have to use the paging file too frequently. And look at the way the system is using the paged pools and non-paged pool memories. The paged pool is an area of system memory for objects that can be returned to disk when they aren't used. The non-paged pool is an area of system memory for objects that can be returned to disk. Look at the way the system is using the paging file. A page fault occurs when the process requests a page in memories and the system can't find it at the requested locations. If the requested page is elsewhere in memories, the fault is called a soft page fault. If the requested page must be retrieved from the paging files on disk, the fault is called a hot page fault. And many processors can handle large numbers of soft faults. Hot faults, however, can cause significant disparate delays. If there are a high number of hard page faults, you might need to increase the amount of memories or reduce the size of the system cache. Counters you can use to check for the memory bottlenecks include available bytes, committed byte, commit limit, page fault per second, pages per second, pages input per second, pages output per second, poor paged byte, and poor non-paged byte, etc. After you have eliminated memory as a potential bottleneck, and you should examine the system's processor usage to determine whether there are any potential bottlenecks. Counters you can use to check for processors bottlenecks include the following. System processor queue length. Records the number of threads waiting to be executed. Processor time records the percentage of time the selected processor is executing non-idle threads. Processor user time records the percentage of time the selected processor is executing a non-idle thread in user mode. Processor privileged time records the percentage of time the selected processor is executing a non-idle thread in privileged mode. Processor interrupts per second. Records the available rate in incidents per second. Let the processor receive and served hardware interrupt. With the high-speed disk available today, assistance hard disks are rarely the primary reasons for a bottleneck. It is more likely that a system is having to do a lot of disk reading and writing because there isn't enough physical memory available, and the system has to page to disk. Because reading from and writing to disk is much slower than reading and writing memory. Excessive paging can degrade the server's overall performance. To reduce the amount of disk activity, you want the system to manage memory as efficiently as possible and page to disk only when necessary. If the system has faster drives than the ones used for paging files, you might consider moving the paging file to those disks. If the system has one or more drives that are doing most of the work and other drives that are mostly idle, you might be able to improve performance by balancing the load across the drives most efficiently. To help you better gauge disk I/O activity, use the following counters, such as disk time, current disk queue length, average disk write queue length, etc. And the network that connects your computers is critically important. Its responsiveness or lack thereof weighs off heavily on the way users perceive the responsiveness of their computers and any computers to which they connect. And counters you can use to check network activity and look for bottlenecks include the following. Network interface bytes, total seconds, records the rates at which bytes are sent and received over a network adapter. A network interface, current bandwidth. Estimated the current bandwidth for the selected network adapter in bits per second. A network interface, bytes received per second. Records the rate at which bytes are received over a network adapter. Network interface, bytes sent per second. Records the rate at which bytes are sent over a network adapter. And Windows Server 2008 introduced data collector sets and reports. Data collector sets allow you to specify sets of performance objects and counters that you want to track. When you have created a data collector set, and you can easily start or stop monitoring the performance objects and counters included in the set. And you can use a single data set to generate multiple performance counters and trace logs. Assign access controls to manage who can access collected data. Create multiple run schedules and stop conditions for monitoring. And use Data Manager to control the size of collected data and reporting. And generate reports based on collected data. And data character set types includes configuration. The configuration type is for data characters that record changes to particular registry paths. And trace type is the data characters that record performance data whenever related event occurs. And performance counters. The performance counter type is for data characters that record data on selected counters when a predetermined interval has elapsed. And when you are troubleshooting problems, you will often want to log performance data over extended period of time, and then review the data to analyze the results. For each data character that has been or is currently active, you will find related data character reports. As with data character sets themselves, data character reports are usually organized into two general categories: user-defined and systems. And you can modify the report details, configuring performance counter alerts. And you can alert to notify you when certain events occurs or when certain performance thresholds are reached. And you can send these alerts as network messages and as events that are logged in the application event log. And you can also configure alerts to start applications and performance log. And monitoring performance from the command line. And Windows Server 2008 includes a command line utility called typeput for writing performance data to the command line. And you can use it to monitor the performance of both local and remote computers. Analyzing trace log at the command line. And you can examine trace log data by using traceput's command line utility. Trace reports processes trace logs and allows you to generate trace analysis reports and dump files for events generated. The available parameters for type wrap are summarized in table. And the parameters for trace wrap are summarized in the table.